Hi guys, it's Mrs. Seitz. What we're going to be working on today is we are going to be learning how to prove lines parallel. So the essential question by the end of today's lesson is, how do you prove that two lines are parallel? So in the past, we've already learned about corresponding angles, alternate interior angles, and so forth. So a part of today's lesson is going to sound familiar to you. However, what we're going to be doing is the flip-flop situation, the converse. So if two lines, for example, in postulate 16, if we have two lines that are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So in the past, we knew that the lines were parallel, so then we were checking to see if the angles were congruent. Now we're starting off by saying, yep, the angles are congruent. Now we're checking to see if the lines are parallel, so we have the flip-flop situation going on. So now we know angles are congruent, so now we know that the lines are parallel. Likely, if we have alternate interior angles, the converse, if we know that we have two alternate interior angles to be congruent to one another, just like angle 1 and angle 3 are in this picture, then we can say that the two lines are parallel to one another. By the consecutive interior angles converse, if you have two angles, like angle 1 and angle 2, adding up to be 180 degrees, then the two lines that they started with would be parallel to one another. So if you have consecutive interior angles that are supplementary, which means they add up to 180 degrees, then the lines are parallel. If we have alternate exterior angles, like we do in angle 4 and angle 5 being congruent to one another, then we can say that the two lines were in fact parallel to one another. All right, we're going to start off by showing how this works with a proof. So for example, let's say we're given that angle 1 is congruent to angle 2. We're going to prove from some things we knew in the past that line M is parallel to line N. So we're going to state first that angle 1 is congruent to angle 2 because that's given to us. We can then state that angle 2 is congruent to angle 3. And the reason for that is because of vertical angle theorem. All right, now, if you look very carefully, you are going to see that we have an angle that's being repeated. And by transitive property, we can cut out that middleman. So we can say angle 1 is congruent to angle 3 now. So I'm going to color that in green. Angle 1 is congruent to angle 3. And if I look very carefully, angle 1 and angle 3, well, those would be corresponding angles with one another. Because I have corresponding angles, the converse of that says that then I can say that line M is now parallel with line N. And I'm going to put those arrows on there to show that the lines are parallel with one another. All right, now I need to find a value of X that's going to make lines P and Q be parallel. Well, it would be really, really nice if these were alternate interior angles with one another so that if I set those to be congruent, then I'm going to say that the line or the two expressions are going to be equal to one another by alternate interior angles converse. So if I say 6x plus 34 equals 9x minus 2, I'm going to start solving that. So I'm going to subtract 6x to both sides. So I'm going to get 34 equals 3x minus 2. I'm going to add 2 to both sides. So I'm going to get 36 equals 3x. And then I'm going to divide both sides by 3. So I'm going to get x equals 12. So the value of x that's going to make these two lines be parallel with one another now is going to be x equals 12 because of the alternate interior angles converse. So lines P and Q will be parallel if the marked angles are congruent. Okay, so now let's see if you got this under control. So see if you can think back on some of those special angle relationships and see if you can find a value of x that's going to make the values of p and q be parallel with one another. Okay, so the relationship I was hoping that you would find is that these are alternate exterior angles. So by alternate exterior angles converse, I could set these guys equal to one another and solve to find the value of x. So if I subtract both sides by 3x, I'd end up with 20 equals 2x. And if I divide both sides by 2, x would equal 10. So by alternate exterior angles converse, then these guys would be, in fact, parallel with one another. Okay, hopefully you found in this relationship you have consecutive interior angles. Okay, now these guys are not going to be congruent to one another. However, they are going to be adding up to 180 degrees. So maybe I shouldn't mark this as the congruent symbol. Okay, I'm just showing you that this looks like that these are the angles we're talking about. So we have this angle here and this angle here. So I'm going to do 13x plus 15 plus 20x equals 180. So when I combine my like terms, I'm going to end up with 33x plus 15 equals 180. When I subtract 15 to both sides, I'm going to end up with 33x equals 165. And then when I divide both sides by 33, I'm going to find that x is equal to 5. So by the consecutive interior angles converse, I'm now proving that these two lines are parallel with one another when x equals equal to 5. Okay, now with this, I'm trying to identify when lines are parallel. Okay, so just by looking at a picture, we can't really make that statement. We have to use what's given to us. So if I look at line AG and I look at line CE, I want to use those, but then I want to think of this remaining line here that I'm highlighting in yellow as sort of like the transverse. Okay, so this yellow is like our transversal. Right, when I take a look at what's left over, I want to see if I can see that there's any type of special angle relationships left over. So if I look here, if I look at the 46 and the 57, or 46 and the 67, when I add those up, I want to see what I might come up with. I'm really hoping that I would get the same type of number here, but I don't see that special number given to us. However, what I do see is the vertical angle relationship right across from it. So what I'm going to do is I'm going to add up those two numbers together. Now, I know just by looking at this that that's not going to be equal to one another, but just to prove it, I know 67 and 50 is going to give me 117 when I add those up. So that means this has to be 117 degrees here. When I add up the 46 and the 67, I'm showing you right now that this is only going to be 113 degrees. So because these two angles are not congruent, this does not meet the conditions of the corresponding angles postulate converse. So therefore, these two lines would not be parallel with one another. All right, I'm going to erase everything that I have here. And I'm going to do the same thing and test out right now to see if BH is parallel with DF. And again, I'm going to use that yellow line to be my transversal. Okay, so right now I'm looking to see if I see any special angles that I could potentially use to try and check this. All right, so right now what I'm looking at, I see there's a 67, I see there's a 46. I could probably start getting some information out of that. I could also look here, right? I got some information that I could use out of this one. So you know what? I actually think I'm going to go with this. Right, I know that this is 67, so therefore this has to be 67, right? All right, if I have by vertical angles, this would also have to be 67. And if I'm still not convinced, I could still try to maybe work off of that. But what I'm looking at is I can definitely see that I have corresponding angles right now. So because of corresponding angles, I have angles that are in the same position because of that converse, then I'm also going to say right now, ignoring the other angles that you see, because you want to just build off of what is actually given to you in the problem. Okay, so that's the important part. You want to make sure you're just looking at the angle relationships that are the ones that are given to you. Okay, that's the part that can get a little bit confusing with this. You want to look at just the 67 and the parts of the problem that are important to you. That yes, this would be parallel by corresponding angles, postulate converse. Okay, so again, on this one here, we're going to check and see if these two rays are parallel with one another. So we're going to be checking in example 3 if BA is parallel with DE. And you might want to think of this line here as being like your transversal. Okay, and in number 4, here's ray BA. Here's ray DE. You might want to extend them. I know they're rays, but we want to see if they're parallel with one another. Okay, so think of that yellow line as your transversal. All right, so here's the numbers that I'm caring about right now. Okay, so right now I know that this is 45 degrees. I really want to know what this angle is here, because if I had corresponding angles converse, I could then check to see if this was 45 degrees, then I could check to see if these rays would also then be parallel with one another. Well, here's how I'm going to do that. I know right now that this two together, so 90 and 45, is going to give me 135 degrees together. I know I have a linear pair when I add up all these together. I have this straight angle, so it has to give me 180 degrees. So 180 minus 135 is going to give me the remaining part that's left over, which is 45 degrees. So since I do have these numbers matching up of 45 degrees, yes, that these two rays would be parallel with one another. So I can say ray BA is parallel with ray DE, and that's going to be by the corresponding angles converse. Okay, and then finally, when we take a look at this last example, these sort of look like to me like alternate exterior angles. So right now I'm going to test the 105, and if I add up the 71 and the 34. So when I add up the 71 and the 34 together, I do get 105 degrees. So by the alternate interior angles converse, so alternate exterior angles converse, ray BA is parallel to ray DE. So the idea in this lesson, guys, is we're now doing the flip-flop. So now we have either the angles are congruent or they are adding up to 180 degrees to then prove that lines are parallel with one another.